All right, welcome to an introduction to logarithms. But before we get into like what a logarithm is, we kind of want to see like what's the problem we're trying to solve? Why do we even need logarithms, right? So if you take a look at the problems that are up on the screen here, there are three of them, and they're all kind of the same, almost the exact same problem. We just change the output values a little bit, right? So the first one says 10 to the x, right? It's 10 to some power is equal to 100. And if we were to think about that in our head, we can probably figure out like, okay, exponent means multiply a bunch of times. So if I do 10 times 10, I get 100. And that means that x has to be 2, right? So I really just multiplied the number 10 by itself twice, right? It's 10 times 10. So I can say that in this case, we really did 10 squared to get 100, okay? And so that means that in this case, x has to be equal to 2, okay? And I can do the same thing for the second problem. 10 to some power is equal to 1,000. Okay, well, that means I did 10 times 10 times 10. That's 3 tens. And so that means that in this case, I did 10 to the third power to get 1,000. Okay, so that means that my x has to be equal to 3. Okay? And I'm able to just kind of think about these problems, and I know the numbers that make 10 become 1,000 or to make 10 become 100, right? But if I take a look at the third problem, now I'm saying 10 was raised to some power, and I got 85. And you're like, I don't know how to do that one, right? How do I get 10 to turn into 85? And this is where logarithms come in, right? This third problem where we're trying to solve for an exponent, we want to know what's that value of x in that exponent spot to make an 85 come out, right? Because that's kind of the way the real world works. It's not always going to come out to be nice numbers like 100, 1,000. You're going to get messier numbers like 85, and we want to be able to solve for those ones as well, right? So that's where logarithms are going to come in. We're going to use logs to solve for that missing x value and figure out how to get 85 to come out, okay? So let's take a look at what a logarithm is. Logarithms are used to find a missing exponent in an exponential function. That's exactly what this problem is, right? We're trying to find this missing exponent in this exponential function, okay? So here's how we're going to do it. We're going to take the traditional exponential form, which is a base raised to some power equals an output, and we're just going to rearrange the parts, okay? So we're going to introduce log, right? This is log, short for logarithm, right? Log. And instead of the base being this this number here, we're going to kind of lower it and put it below the log, okay? And then the old output, okay, the y value is going to go next to that, okay? And then the answer to our log problem is going to be the exponent, right? So instead of this being base exponent output, now we're saying log of some base output equals exponent, right? So all the parts are there, they're just kind of in a different order. So take a look at this example below and it will make more sense. And we'll do a couple of problems together, okay? So this example says, all right, let's start off with the exponential 5 squared equals 25. I think everyone agrees that's a regular good equation, okay? So it's base of 5, exponent of 2, answer 25. That's the output. All we're going to do to put this in log form is rearrange the parts, okay? So my answer here, okay, is log, and I'm just going to write the word log. That tells me that I'm kind of rearranging things. And I'm going to put a little subscripted 5, right? That's the base, right? That goes below the log, okay? And then my output value, right? What was on the other side of the equal sign, right? Was the 25, okay? And then that log base 5 of 25 is going to be equal to 2, right? Which is my old exponent. And the way that I would read this is I would ask the question, 5 to what power gives me 25, right? So it's literally exactly what we're just doing here. We're saying 10 to what power gives me 100. 10 to what power gives me 1,000. In this problem, when I write log base 5 of 25, what I'm saying is 5 raised to what power gives me 25. And that's why I'm able to say on the other side that the answer is 2. If I say 5 to what power is 25, oh, okay, well, 5 to the second power is 25. So I'm going to say that the answer is 2. Okay, so we're going to take this problem and we're going to try it a few more times. We're going to try to convert some logs. Okay, and here they are. Okay, so if I take this first problem, it says 10 to the third power equals 1,000. We just did that one, but let's write it in log form now. Right, so I'm going to say log. Okay, my base is 10, so I'm going to put a little 10 down here. Okay, my output value was 1,000. Okay. And now this is asking the question, 10 to what power gives me 1,000? And I'm going to say, oh, that equals 3. 10 to the third power equals 1,000. Okay. The next problem is doing the same thing. It's saying log. Let's get a different color. Log. Okay. And then my base is 6, so I want to make sure I indicate that. And my answer is 1296. So I'm asking the question, 6 raised to what power is 1296? And the answer is 4. If you do 6 times 6 times 6 times 6, you get 1296. Okay. Third problem, same idea. I'm going to say the log. Okay. My base is 8. Okay. My outcome is 512. And so I'm asking myself the question here, 8 raised to what power is 512? And the answer is 8 times 8 times 8. There are 3 of them. So I'm going to say 3. And my last problem looks a little different. It's got a variable in it, but I'm going to just do the same thing. I'm going to say log. Okay. I'm going to take my base of 3. Okay. And then I'm going to say I want an outcome of 27. So I'm asking myself 3 to what power gives me 27? And in this problem, I don't know. So I'm just going to put the X, right? But now I can look at this and say, oh, 3 to the third power equals 27. So I know that this X value would have to be 3, right? So in all of these cases, all we did was just rearrange the parts and bring that log in at the beginning, right? And then just started asking myself the question, 10 to what power is 1,000? 6 to what power is 1296? 8 to what power is 512? 3 to what power is 27, right? And if you keep asking yourself that question, you're going to see that that's going to help us to eventually be able to solve problems like that first one, 10 to what power is equal to 85.